Now, logarithms is typically found as some of the toughest part of Algebra 2, but I think we're going to be able to handle it. We'll take it piece by piece and hopefully have a lot of practice with it. Let's first talk about what is a logarithm before we can even talk about how to do it or how hard it is. Now, first I just want to talk about inverse functions or inverse operations. For example, x plus 4 equals y. Well, if I wanted to get the x by itself, that's the same thing as doing x equals y minus 4. So positive and negative are inverses. We kind of knew that already. Multiplying and dividing are inverses. We also knew that. Doing something to the second power is the inverse of square rooting something. It should be x. We knew that. So as you notice, these are just opposites from each other, right? Or inverses would be the proper term of each other. Plus and minus, times and divide, squaring something and square rooting something. So what we're learning today is a new type of inverse. It's a new type of inverse. So this is the general formula. Let's say if you had some function, some number, b to the x power equals y. B to the x power equals y. Well, the opposite of that, or the inverse of that, is taking the base, that's why it's b, the base of the exponent, and becoming a different type of base. It'll be x equals, this is what's new in green, log that little b, it's like a little sub b of y. This is what a log is. A log is just the opposite of being the exponent. The log is the opposite of the exponent. Or I should say more particularly, the base of a log. So the base of the... What's up? I'm not even going fast. Going fast. I feel like I'm going so slow. I feel like I'm on molasses.
I'm still on x plus 4, okay?
Whoa. That's too slow. That's not me going too fast. Get that done. Either way, these are opposites. Base of an exponent. Never spelled that right. Is the opposite of base of a log. So the base of an exponent is the opposite of the base of a log. That is the most important part about this section. That is what a log is. Okay, I'll put it back up, don't sweat. That previous stuff doesn't matter. You already knew plus and minus are opposites. You know multiplication, division, opposites. This is what's new. Base of an exponent being opposite of a log. Okay. So what do I mean by that? Let's take an example. Three to the x power equals 9. 3 to the x power equals 9. Anyone wants to speak up and say, what is the x here? Or what should the exponent be? 3 to the x power equals 9. What exponent could I plug in for x?
3 to the second power.
Thank you, Nahum. 3 to the second power. Now, guys, it's so loud in there. Nahum, I'm sure Nahum's in front of his computer. I barely could hear him. Just be quiet. Or don't. Just don't do well on the next test. I don't know what to tell you. So this 3 to the x power equals 9. And, you know, if you're paying attention, you could tell that x should equal 2. Now, if I were to write this as a log, I would take the base of the exponent, which is 3, and move it to become the base of a log. So it's x equals log the base of the log. So it's a tiny little 3 to the capital, a normal size 9. X equals log base 3, 9. Okay? So this is changing it from exponent to log. What we could also do is change it from log to exponent. So log base 2, let's do 32 equals 5. Log base 2, so a small 2, normal size 32 equals 5. Converting it to its own different thing, what it becomes is when it's a base of a log, it becomes the base of an exponent. So 32 equals 2 to the 5th power. Notice this 5 kind of got moved up or kind of picked up to become an exponent, because 2 will become the base of an exponent. So if you have a base of an exponent, it becomes a base of a log. If you have the base of the log, it becomes the base of the exponent. So log lowercase b, I think you usually use x equals y. So this right here is a generic log where b is the base of log, or this little number, in this case would be 2, or in this case would be 3, is the base of a log. Same way you have a base of an exponent, you have the base of a log. I'll leave this up for a half a minute. If anyone has any questions, you can speak up.
Good question.
Go ahead.
Is so does y always how do I put this? Does y always become the exponent?
Yes, y will always become the exponent. When you move it over, it stops being the base of a log and it becomes the base of an exponent. So you could draw a little conversion, would look like this. X equals b to the y power. If you want to draw a little conversion next to it. Good question. All right. Yep. All right. Let's talk about a couple of problems here where we're going to write it in exponential form. We're not doing any solving. We're just converting logs into exponents and exponents into logs today. That's it. Okay. So I'm going to do the first one, and I'm going to leave the 3 for you to practice, and then we're going to go to the next page afterwards. What we have here in A is log 2 32 equals 5. Good job, Nahan. This log base 2, you got it right now, is going to become 32, this is a conversion, equals 2 to the 5th power. So this is changing it into exponential form. And if you notice, 2 to the 5th power, 2 times 2 times 2 times 2 times 2 is 32, which I just realized accidentally, this is an example that I made from before. Okay. Everyone, take your notes and try these 3. Take your notes and try these 3. Nahem, I agree for letter B. I agree with that one. Everyone should be trying this. I agree with C, Nahem. D is now a trick question. All right, let me go through the answers. It's pretty straightforward. Take the base of 10, move it over here. 1 equals 10 to the 0 power. And keep in mind, 10 to the 0 power is always, anything to the 0 power is always 1. So that works out. Let's go to the next one. 9 equals 9 to the 1 power. That also makes sense. 9 to the 1 power, or anything to the 1 power, it's itself. So that makes sense. Last one, a little bit tricky to see at first, but you have to remember something about negative exponents. If I were to ask you to solve this, you would do 25 equals negative exponents, bring anything in the basement to the top and anything to the top to the basement. So 1 over 5 becomes 5 over 1, or just 5. That becomes a positive exponent. And 5 squared is definitely 25. Now, remember, I didn't even ask you to solve it. I just asked you to rewrite it. That'll be one part of your homework. Any questions on the rewriting? I will say this, Nahem, you change it to decimal is okay. That's fine if you want to change it to decimal, but no real need to.
Wait, how did you switch it from 1/5 to 5?
If you remember negative exponents, I'll just draw a random example. 3x to the third, y to the negative fourth, z to the 2, a to the negative 3. Anything to the negative exponents, switch sides. So y would go down and a would go up. Once it switches sides, it'll become positive. Sorry for the ordering being messed up, but you get the idea. Now, when it comes to a full fraction, you technically, what happens is you distribute the negative 2 to here and here. So you technically have 1 to the negative 2 over 5 to the negative 2, which means if I were to make it positive, 5 squared over 1 squared. Well, 1 squared is just 1, and this is a whole number, so it's just 5 squared. Negative exponents flip fractions. That's all you need to remember. Negative exponents flip fractions. Which is a good question because next section, if I remember it correctly, is how do you evaluate it without a calculator? It's kind of tough sometimes. So let's talk about it. I'm going to do the first 3 and I'll leave the 4th one as our exit ticket. No, I'll put a secret one. I'm not sure. Let's talk about it. So this is our second section and the last section of today. How to evaluate this without a calculator. So step 1, you're just going to set it equal to some variable. X, Y, doesn't matter. So we have log base 3 of 81 equals Y. You can make it X, you can make it A, you can change the variable to whatever you want. So what you're going to start off with is to change the log into an exponent. So your first step is 81 equals 3 to the Y power. All I did is took the base of the exponent and turned it into the base, a base of a log, and turned it into the base of the exponent. Kind of like I did all in the last page, just with a variable. Now this is the tough part. You could use a well, I said not to use a calculator, so don't use a calculator. I have to think really hard. How do I make 3 into 81 with some exponent? If I didn't have a calculator and I'm struggling with this, I'm going to have to do a little bit of math. Well, 3 to the first power is 3, so that doesn't really help. 3 to the second power, 3 times 3, is 9. No, that's not it. 3 to the third power. That's 3 times 3 times 3, 27. Well, that's not it. 3 to the fourth power, 3 times 3 times 3 times 3, which is 9 times 9, which becomes 81. Wait a second. Look here. 3 to the fourth power gives me 81, which means 81 equals 3 to the Y power. There's only one number it could be. Y equals 4. So your answer is Y equals 4. All right. So you have to figure out what to do and how to do it. Let's do the next one together. And this is pretty important because we're dealing with a fraction. Maybe we could handle it. So we have log 1/4 256. I'll put equal to Y. All right, bring the base of the exponent to become, or base of a log to become base of an exponent. 2, 5, 6 equals 1 to the fourth to the Y power. Now you should notice something. This is a fraction. This is a whole number. So what we're going to do, great. What we're going to do is we're going to have to definitely get a negative exponent. So I'm going to start off by writing it like this. 256 equals 4 to the negative y power. I have to flip it because I need this to be a whole number. So when I do this whole number to some power, I could get to a whole number itself. So 256 equals 4 to the negative y power. Let's start doing that. Well, it's got to be 4 to the 1 power. Nah. 4 to the second power, 4 times 4, which is 16. 4 to the third power, 16 times 4. By the way, notice you could just always just do times 4, times 4. Kind of like here, we did times 3, times 3, times 3. 16 times 4, 64. Well, that ain't it. 4 to the fourth power. You know, it took a long time in my head, but it's okay. 64 times 4 is 256. Hold up, wait a minute. That's what our answer was. Don't forget the negative, though. Don't forget the negative. So your answer here is y equals negative 4. So the exponent that would cause 1/4 to become 256 is y equals negative 4. Okay. A question that could potentially be asked, do we really have to do the math? Like this math? If you don't know your powers, yeah, you're going to have to do the math. Let's go to letter C. Log base 10.001. Log base 10.001. Got to set it equal to y. And then bring it over. 0.001. I don't know why I put 3 zeros. 2e here, I guess. Equals sum 10 to the y power. Something's weird. 10 is bigger than 0.001. Which probably means that instead of doing to the 10 power, I'm going to have to do a negative because now I'm taking, here I had a small number, I got to make it into a whole number. Here I have a whole number, I got to make it to a decimal or a fraction, doesn't matter which way you think of it. So I'm going to set this up as 1/10 to the negative y power. So if I have a whole number like this, and I start with a fraction, I'm going to have to use a negative. If I have a non-whole number or decimal or fraction, and I have my whole number here, I'm going to have to change it to negative. Basically, if they mismatch, whether one is a decimal and the other one's a whole number, or one's a whole number and the other one's a decimal, you're going to have to use a negative exponent. Now, I do say not use calculator. I mean, don't use the log button. You don't know how to use the log button yet, actually. So I'm not worried about that. But if you need a little help with your math, that's fine. 1/10, by the way, is the same as 0.1. So I don't care which way you do it. Okay, 0.1 to the 1 power is just 0.1. 0.1 to the second power is 0.01. 0.1 to the third power is 0.001. However, you need to take your time to figure it out. You'll figure it out. I usually just circle the exponentially. So I know it has to be a 3. Do not forget it was a negative y though. So y equals -3. Okay. All right, everyone who's logged on, try to do the for an exit ticket. Then I'll let you guys go. Post some homework later. Pretty straightforward stuff. Try a letter D. In this situation, I would try to walk around, but you know, I'm at home, so it doesn't really work like that. My thing is getting smaller. Actually, you know what? This is too tough. Screw this. I'll figure out some better problems for you guys. You will have to use a negative exponent, but I just realized I talked about this and it's not the same. So my fault on that. I'll just call it a day for you guys. Type here and then have a wonderful day, okay? I'll post some homework for you later.
Thank you.
No problem.
Thank you very much. Have a great day, Mr. Shabal.
You too. Cool. No problem, Ella.